conducting the Shapiro-Wilk test is actually one of the easiest hypothesis tests to conduct. What it's going to let us do is test a claim about the normality of our data. And the reason I say it's one of the easiest tests to use is that it always uses the exact same two hypotheses. So unlike some other tests where we always have to identify the claim and look at constructing those two statements, for the Shapiro-Wilk test, we always have the exact same null hypothesis, which is the assumption that our sample data comes from a normally distributed population. And we have the alternative hypothesis that our sample data comes from a non-normal population. So keep in mind with any hypothesis test, we always assume that the null hypothesis is true unless our data has enough evidence to convince us to reject that statement. So we're always going to start off with the assumption that all data comes from normally distributed populations, which we've seen from examples throughout the course that that's not true. So if there's enough evidence, we'll reject that statement and end up concluding the alternative statement, which is that our data comes from a non-normal population. So it's easy to conduct this test because those hypotheses are always the same, meaning that reaching our conclusion is always going to be the same process. So our test will result in a p-value, which will then let us conclude if our population is normally distributed. If our p-value ends up being something less than or equal to our alpha value, so that significance level, then we'll reject the null hypothesis. So if we reject that null hypothesis, we're saying that there's enough evidence to conclude that our data comes from a non-normal population. So we would conclude that our population is not normally distributed. If our p-value is something greater than alpha, so larger than our significance level, then we would fail to reject the null hypothesis and conclude that our population is normally distributed. So something to keep in mind is, again, the idea that with hypothesis tests, we're not proving anything to be true or false. If we fail to reject the null hypothesis, it could be that our data actually comes from a non-normal population. We just don't have enough evidence collected. So if we collected a larger sample or a different random sample, it's possible we could come to a different conclusion. But all we're saying is, in this case, with the evidence we have to consider, there's not enough evidence to reject that original assumption. So we assume that our data is normally distributed.